Today we'll look at a classic Go interview question. At first it seems simple, but it actually catches a lot of developers. If you really understand it, you're already ahead of most candidates.
We have a loop. Inside the loop, we start Go routines that print the value of the loop variable. At first glance, it seems obvious. The loop goes from 0 to 4, so the Go routines should print the numbers 0, 1, 2, 3, and 4. Right? Well, not really. Here's the catch. When you start a Go routine with a function, it does not run immediately. It is only scheduled to run. The Go scheduler decides when to actually start it. The loop itself runs much faster than the scheduler can start the Go routines. So the loop finishes, the main function ends, and the program exits. This means that sometimes no Go routines run at all. Sometimes 1 or 2 run, but the behavior is unpredictable. That's mistake number 1. People think Go routines start right away, but when main ends, all unfinished Go routines die. So, how do we fix this? We need to make sure the main function waits for all Go routines to finish. One simple but naive way is to pause the program for a certain time. For example, pause for 1 second. Sometimes this works. Sometimes it does not. 1 second might be too short, or it might be too long and just waste time. It is not a reliable solution. The proper way is to use a wait group from the sync package. Here's how it works. You tell the wait group how many Go routines you expect. Each Go routine calls done when it finishes. And in main, you call wait. That blocks until all are done. Now main won't exit too early. In older versions of Go, the loop variable used to cause problems because Go routines captured it by reference. In the latest versions, Go handles this correctly. Each iteration of the loop now has its own copy of the variable. So Go routines started inside the loop print the expected values. 0, 1, 2, 3, 4, just as you would expect. This change makes your code simpler and more reliable. You no longer need workarounds like passing the variable as an argument or creating a local copy. However, it's still good to know how it worked before because some legacy code may still use the old pattern. Why is this question so common in interviews? Because it tests several skills at once. Do you understand how Go routines are scheduled? Do you know how to synchronize them? These are all real-world skills. Let's add a small twist. What if we tell Go to use only one CPU core? Some people think this means Go routines will run one by one in order. But in practice, the results can still surprise you. You may see different outputs each time you run the program. Why is that? Because concurrency is not the same as parallelism. Even on a single core, the scheduler can switch tasks in unpredictable ways. So here's the final lesson. Never assume Go routines run in order, unless you explicitly control them. This tiny example teaches a lot: scheduling, synchronization, closures, and the difference between concurrency and parallelism. Now I'm curious, did you know about this Go routine issue before, or was this new for you? Let me know in the comments. And if you want more simple explanations like this, don't forget to like and subscribe.